the concept, it's like we are the Atlantic, the Atlantida, if you want to think in that way, because we are under some kind of gases, liquid, you can put the name, but this gas is called, let me show you official sites. I have it in Spanish, right? But maybe you can see. It's called SF6.
Oh, hexafluoride. Okay.
Yeah, and this for the official science, they are totally aware the atmosphere is composed with this gas, also with the dioxide. ¿Cómo se dice dióxido de carbono? Carbon dioxide. I don't know if I pronounce it well.
Yeah, carbon dioxide. Yeah.
Yeah.
Yes.
Yeah. So the carbon is 1.4 more heavy than the air, and this gas is 6 times more heavy than the air. So the people in the media, just for fun, they make. Let me show you. Because I don't have this this subject ready to go, but I can show you. For example, the media, when get fun with this kind of gases, they show you, and for me it's very interesting what this gas can do. First of all, it's invisible, totally invisible. You doesn't perceive that this box is full of this gas, but when you drop it, some lighter object, they float.
Wow, and this gas is called sulfur hexafluoride.
Yeah, that
Right.
is the name of this gas. And not just they float, they act like water. The movement, the turbulence, all that kind of stuff is like water. In fact, you can take and put inside, but you can see how this object sink down.
It's
So
also
that-
described, Iru, disculpa, it's also described as having, you'll like this, Bob, excellent electrical insulator. It's part of
That's-
its qualities is as an excellent electrical insulator.
Very
Like,
good.
okay,
Yeah, and-
so how is it, if it's so dense, how is it doesn't fall down onto the earth, given that it's so much denser than the air above which it's situated? Well, it's because I would say, the electromagnetic field of the earth keeps it apart, because it's an insulator.
Yeah, I would
Acts
tend
like
to
a
agree.
dielectric.
I would tend to agree with that.
Yep. Very good.
Yeah, in fact, this gas has the property too. It's really heavy. They shoot down all the flames, so that is something that happened to the rockets. Also, it's an electrical isolation, and also it's diminish the frequency of the sound. So when you start to, I'm going to show you a few things, but let me just, they drop little bubble, they all leave that floating. I have a video, with very deep analysis of this gas, but I going to try to put the
Bob,
parts that I.
Bob, you're going
that
to
I
love this too, because when he shows you the sound properties, I've been doing a lot of research into your video, your balloon footage, and the sound differences when the balloon got higher. You're going to love this. Watch.
Okay.
That's right. That's right. And well, here I'm gonna put the sound because it's in. No, pardon. It's sorry. It's my voice. But here you can see in the media that they have fun with this. But if you look it's just like a fluid, but it's a gas. All right. Now this gas has a property. When the gas get really cold, like 0 Fahrenheit, for example, this gas take a property of crystal. So when you start to put this all together, let me show you what I want. Sorry for the situation, going back forward. Here is the superhelium, properties. When it's cold, they lose all refractive index. so it's totally invisible also. So you can determine if it's something up there or no, because you doesn't have any property of index of refraction. So that is also maybe what we see when we see the light project on the top of the atmosphere. And when you keep going, let me try to, here you can see there is no index of refraction, for example, which is something really, and then here is a little process trying to, because this gas has also the color of the ozone layer. When when these kind of gases have a different temperatures, they react some different. It's the same gas, but react different ways, and all that ways that these gases take, this chemical reaction. It's the same reaction that we see when we look up in the sky. For example, the colors, the properties itself. And I'm going to show you a little more advanced. And here is a lot of, kind of videos from DLR, which is a Germany company. It's a government sorry, it's from the government company. It's like NASA, but in Germany.
Right.
And
overpaid liars.
Yeah, yes, that's right. And then also send to the top this sounding rocket, and they found the same thing. They enter in this like microgravity, 6 minutes of microgravity. They cut off the video. But when the stereo see, you can see like maybe the rocket changed some temperature on the air, and because all this happened only when the rockets enter again to the normal, fluid condition of the atmosphere. So it's a little, it's a little strange, because nobody goes top of 120 kilometers, 150 kilometers. No, any ships go, so far, and all the ships, all the rockets that reach that altitude, all have stuck on there, and that altitude. And the behavior, in fact, the behavior is like they are on some kind of gas. Yeah.
I was just going to say, I'd like to get me some sulfur hexafluoride. I was just looking into that a little bit. It's pretty interesting stuff, man. It's a hypervalent gas, hypervalent molecules. And so, I mean, I guess that would sort of be like adding a bunch of, like a lot of salt, super salinated water. That's what they put in sensory deprivation chambers, is creates more buoyancy. So do you think that there's, because it makes sense to me that there would be layers of different density gases, even higher density gases at higher levels, if that was conducive for that frequency of the magnetic field at those altitudes, like Antonio mentioned. I definitely agree with that, but I'd really like to get some of that and like fill a car up with it and just have like bubbles floating around in it.
It also makes it has the opposite effect of helium on your voice. So when you inhale it, your voice goes deep.
Yeah. So, yeah. I want to show you that. In fact, there is something that I'm trying to forward the video, because I'm trying to to find that part. But also there is something very important for me, because which is on the nature what produce the hexafluoride of azufre. It's the volcans.
The volcanoes.
The volcanoes, yeah. So that the volcanoes is like it's which is the nature that has put that barrier on top. Anytime a volcano make eruption, it fill the atmosphere with this kind of gases at it's uncalculable. You can say how many. So this is it's part of this kind of the design, intelligent design. In fact, when you see this kind of statistics, the officials say that to 100 kilometers up, the temperatures go down and suddenly go up. But if you never go so up, how do you know?
Yeah, yeah.
The problem is that if you continue the line to, the point that when the science really can prove this, if you continue this line, it's going to get more cold up there. And if get more cold, it means that this gas is turned into crystals. So that maybe is the reference, in all these religious philosophy that we live in on crystallized dome, on these kind of things.
The firmament.
The firmament, exactly. This gas has the property to transform in crystal if the temperatures go down. All these things that I telling you, I can show you, right? I don't have the material prepared to make the show a little fast, but it's all online. You can research and you're gonna see the same thing that I show you.
Yeah, well, I wouldn't worry too much about that, Eru, because you will be coming back.
Okay, thanks.
You've got tons of great information, and the audience so far is absolutely loving everything that you're presenting. So, absolutely, this is great stuff.
Yeah.
Yeah. So this gas, for the real science, they tell all the equivalent, all the they say, okay, it's up there. It's more heavy than the air, but it's up there because the dioxide of carbon is also more heavy than the air, and it's up there also. So there is this kind of electrical properties that have the firmament, that kind having this kind of gases up there.